Namaste, and welcome to another exciting episode of Paul Talk Statistics. I'm your host, Dr. Chinmoy Pal.
And I'm your co-host, Ria. In today's episode, we are diving into a very commonly used yet often misunderstood topic in statistics, the Z-test.
Ah, yes, the Z-test. It's one of the foundational hypothesis tests we use when we want to know if our sample data tells us something significant about the population. But before we go technical, let's begin with a simple question.
Which is?
Have you ever wondered whether a medicine is really effective or if a new teaching method actually improves student scores? In such cases, we collect sample data, and then we need to test if what we observed is just due to chance or if it really indicates something meaningful. That's where Z-test comes in.
Segment 1. What exactly is a Z-test?
So let's define it properly. A Z-test is a type of hypothesis test used to determine whether there's a significant difference between sample and population means or between two samples. It's used when the population variance is known and a sample size is large, typically n greater than 30.
Correct. The test statistic, called the Z-score, tells us how many standard deviations our sample mean is from the population mean. If that number is too high or too low, we may conclude that the difference is statistically significant.
Absolutely. And once we calculate the Z value, we compare it with the critical value from the Z distribution table, usually for a confidence level like 95% or 99%. If the Z value falls beyond the critical value, we reject the null hypothesis.
Segment 2. Formula and interpretation.
Let's give them the formula. Z is equal to x bar minus mu upon sigma upon root n, where x bar is the sample mean, mu is the population mean, sigma is the population standard deviation, n is the sample size.
Absolutely. And once we calculate the Z value, we compare it with the critical value from the Z distribution table, usually for a confidence level like 95% or 99%. If the Z value falls beyond the critical value, we reject the null hypothesis.
Segment 3. Real-life example.
Shall we take a real-life example?
Yes, let's say the average height of adult males in India is 167 centimeters. A researcher thinks that the average height in a particular city is different. So, he takes a sample of 100 men and finds the mean height is 170 centimeters with a known population standard deviation of 6 centimeters.
Now, using the Z-test, we can check whether this difference of 3 centimeters is statistically significant or just a random variation.
Exactly. We compute the Z-score, and based on the result, we decide whether to reject or accept the null hypothesis that there is no difference.
Segment 4. When not to use Z-test.
Very important point. Z-test is not suitable when the sample size is small or the population standard deviation is unknown. In such cases, we use the T-test instead.
Also, Z-test assumes that the data is normally distributed. If that assumption doesn't hold, we might need a non-parametric test.
Segment 5. Summary. To summarize, use Z-test when sample size is large and greater than 30, population standard deviation sigma is known, and you want to compare sample mean to population mean or between two sample means.
It's widely used in medical research, quality control, education, and even marketing. A small formula but powerful decision-making tool.
Well, that wraps up today's discussion on Z-test. Hope it helped clear your doubts and gave you confidence to apply it in your own research.
If you enjoyed today's episode, do share it with your friends and colleagues, and don't forget to subscribe to Paul Talk Statistics on Podcastle or your favorite podcast platform.
This is Dr. Chinmoy Pal
And Ria,
signing off. See you in the next episode. Till then, stay curious and keep learning.